So today we're going to be talking about specific heat capacity. All right, we're going to be talking about specific heat capacity, which is a concept that we used during our project-based learning. Okay, during the solar oven competition. Now, one of the things that I asked some of your groups to do is to research on specific heat capacity and actually how does it affect the solar oven lah. Okay, how does it affect the heating up of the water? How does it affect the cooking of the egg? So this is a very important concept. This is, as I said in a previous class, or at least in a previous life, that this chapter is considered to be one of the more difficult chapters in the whole of Form 4, because there is not just a lot of calculation, but there's also a lot of concepts that need to be grasped. There's a lot of unlearning lah. You have to unlearn a lot of things, and you have to learn this new thing, which is actually not new. It is just the truth. Okay, sometimes, yeah, your whole life has been a lie so far until you learn physics from 4 lah. Then you learn that, oh, actually this is what happens. So you kind of have to unlearn what you learned before, and you have to learn this thing lah. And one of those things is this thing called specific heat capacity. Now, when we talk about specific capacity, we have to first talk about heat capacity. We have to understand what is the meaning of heat capacity. Okay, in Malay it's muatan haba. Okay, how much heat, okay, can you contain? How much heat can you store? Okay, that's why it's called capacity. Okay, how much, like your, like your mental capacity lah. How much mental can you contain? How much emotional capacity? How much emotions can you contain? So when we talk about heat capacity, we're talking about how much heat it can contain before something happens. Okay, so let's take a look at this situation. So this guy is standing on the sand, which is on a hot day, which is kind of like bodoh lah. Okay, I don't know what this guy is doing. And obviously he's going to say, ouch, the sand is hot. Okay, if you have ever been to the beach before, you obviously know this. The seawater is pretty cool, even on a hot day. Okay, and look at this, it's an interesting thing, because both the sand and the water are receiving the same amount of heat from the sun. If you think about it, it's not like the sun is pinsam, atau berat sebelah kan. The sun gives more heat to the sand, and then the sun gives less heat to the water. No, that's not the case at all. And the sun actually gives the same amount of heat to the water and to the sand. But the question is, why does the sand, okay, get hot quickly compared to the seawater? Okay, the sand gets hot quickly, the seawater gets hot slowly. It makes a lot of sense. So that's the question. So this one can be explained by this concept which we call heat capacity. And it is the keyword for today. Okay, don't think about all those things that you learned when you were in standard 4 or whatever lah. Okay, now we are Form 4 already. We have to up our level of understanding. We cannot remain in our 10-year-old self. Okay, so different objects have different heat capacity. The first thing you need to understand. Okay, different objects have different heat capacity. Different objects are able to store different amounts of heat. Okay, so in this case, sand has a low heat capacity, okay, and it gets hot quickly. That's why it gets hot quickly, because it has a very low heat capacity. Means it's able to store a little bit of heat before it gets hotter. Seawater, on the other hand, has a high heat capacity, and because of that, it gets hot very slowly. And this makes sense to us, every day we do this. Okay, how many of you have tried to boil water and boil sand? Sorry, fine lah, boil sand lah. Okay, at the same time, you find that sand becomes hotter much faster. Water takes a very long time to get hot. It does get hot, but it takes a very long time to get hot. Okay, simply because sand has a small heat capacity. Okay, so this connection is something that I want you to remember right at this very beginning. Astaga, sekejap. Okay, this connection is something that I want you to remember right at the very beginning. Okay, where sand actually gets hot. This one, low heat capacity means gets hot faster. High heat capacity means gets hot slower. Okay, and even the other way, it works the same thing. Same thing. Okay, during morning, a boy puts a pail of water from a swimming pool near the pool. So there's a pail of water, and there's swimming pool lah. Okay. Now during the afternoon, the boy puts one hand into the pail and another hand into the swimming pool. Okay, and this is what he's going to observe. He's going to observe that both the temperatures are different. Let me ask you, which water is going to be hotter? The water in the swimming pool or the water in the pail?
Water in the pail.
Water in the pail. Okay, water in the pail is going to be, thank you. I don't know who answered that, but thank you. So water in the pail is obviously going to be hotter than the water in the pool. Okay, so when we talk about heat capacity, we're not just talking about the type of material. Just now was sand and water. Sand and water are two different types of material. They have different heat capacity. But in this case, even the amount, even the amount of material you have also affects the heat capacity. The water in the pail will get hotter because the water in the pail will have a low heat capacity because there's less water. Okay, also another important thing to think about. The water in the pool and the water in the pail have different heat capacity. That's why the water in the pail gets hotter faster. Okay, and so I think, this is also not in this one. Okay, same thing, water and cooking oil. Okay, have the same mass and you give it the same amount of heat. Okay, and you find that the temperature of the cooking oil becomes hotter faster than the water temperature. Don't believe, you go and take okay, take the same amount of oil and the same amount of water, and well, now you all have the thermometer, right? You can do this lah. You cook the water and you cook the oil for 5 minutes lah. Okay, then you put the temperature, you put the you put the thermometer inside. Okay, you will find that actually the cooking oil becomes hotter faster, okay, than the water. And because of this, we also understand that water and cooking oil have different specific heat capacity. Okay, so the first thing we need to ask ourselves is, what is the meaning of heat capacity and specific heat capacity? Okay, open your modules to this activity number 1. Okay, and this one has already been answered lah. Okay, which water is hotter? You find that the water in the pail is hotter. Okay, which water has the smaller mass? Somebody?
The pail.
Water
in the pail. Okay, so water in the pail has a smaller mass. So which water needs to be exposed to the sunlight in a shorter time in order to raise its temperature by 1 degree Celsius? Let's say you want to kasih tingkat the temperature of the water in the swimming pool and in the pail by only 1 degree Celsius lah. Who needs a shorter time? Water in the pail or water in the swimming pool?
Water in the pail.
Water in the pail. Very good. Okay. So this is something that actually we already know, You think about it, this doesn't even require like a super scientific mind. Okay, this is something that we already know. Okay, except that now we are going to give a proper explanation to this. Okay, D, which has a larger heat capacity, the water in the pail or the water in the swimming pool? Which needs a lot of heat?
Swimming pool.
Okay, water in the swimming pool. Okay, so the inference is this, the higher the heat capacity, okay, the lower the temperature rises. And you need to put at the back here so that you understand yourself, the lower the temperature rises means that it is slower to rise, slower to become hotter. Slower to become hotter. Okay, very important understanding that we need to have. The reason why anything takes a very long time to become hotter, okay, is because of the heat capacity. How much heat it needs in order to become hotter. So things with high heat capacity, okay, like the water in a swimming pool, it will take a longer time to become hotter. Okay, the temperature increase will be very small. Precisely why I asked you to do the PBL first before I taught you this, so that this makes sense to you. Throughout this whole subtopic, think back about the PBL that you did. Okay, think back about the PBL you did. What could you have changed in terms of the heat capacity to make This one, especially, especially the egg. Okay, especially the egg. What could you have done to, to change the condition of the egg? So, heat capacity of an object is the quantity of heat that you need to raise the temperature of any object by 1 degree Celsius. So, basically is how much heat I need to increase by 1 degree Celsius. Okay, this is the definition of heat capacity. Okay, quantity of heat, how much heat you need to raise the temperature, okay, by 1 degree Celsius. Okay, the basic amount lah. Of course, if you want to know the amount of heat okay, then obviously you have to you want to know the amount of heat for 2 degrees Celsius, 3 degrees Celsius, that one is different but heat capacity, okay, heat capacity is a constant okay, it is a constant that tells us how much heat we need, okay, in order to raise the temperature of a material, of an object, by 1 degree Celsius. And so the unit for this will be joules per degree Celsius. How much heat per 1 degree Celsius? Okay, so this is the basic formula for the heat capacity. Let's do an example question. When 2000 joules of heat, okay, is supplied to objects X and Y, so you have 2000 joules of heat, which is the letter Q. Okay, object X experiences a rise in temperature of 1 degree Celsius, which is this one, delta theta is 1 degree Celsius. But object Y pula, okay, delta theta is equals to 2. Okay, so I'm going to say this is Y and this is X. Okay, so take note of this. Okay, if you take a look at the situation, automatically you can tell me, between X and Y, who has the bigger heat capacity?
X.
Why X?
Because 2000 joule only rise in 1 Celsius,
Hmm.
but object Y rise in 2 Celsius.
Very good. Because you provide the same amount of heat, but Y becomes hotter faster. Okay, it naik 2 degrees Celsius when you supply the same amount of heat with the same amount of time. So obviously Y has a smaller heat capacity because a little bit of heat terus panas sudah. And you can think of it in terms of like this lah. Somebody with a very small heat capacity is like somebody with a very short temper. Okay, sikit saja kan terus dia panas sudah. People with big heat, things with big heat capacity dia lambat jadi panas mah. Orang yang panjang sabar lah, people who are patient, people who are, it is very difficult to make them angry. These are people with big heat capacity. I'm not saying one is better than the other. I'm just saying that this is a good comparison. Okay, you can think of things with small heat capacity, like people with short temper. You just say their father's name also, wow, they already so senchi, they already marah already. Kau ejek nama bapak dia, terus dia marah. Okay, but some people you ejek until their grandfather, their moyang pun kan dia like, okay, don't care. So there are people with big heat capacity because it takes a lot to make them hot, to make them angry. Okay, I'm not saying that you should annoy people okay. So what is the heat capacity of object X and object Y? So let's do this example, this one. So the formula will be C equals to Q. Q is the standard standard symbol for heat, okay, over 1 degree Celsius, delta theta lah. Okay, so you get this one, 2000 joules per degree Celsius. Okay, and object Y, same formula, same amount of heat, except that the increase in temperature is different. So you find that object Y has a smaller heat capacity. So when we compare, when you compare the heat capacity of objects X and object Y, how would your answer be like? I have taught you already how to write a compare answer. Can you give me the answer, please? Give me the answer in full sentence.
The heat capacity of object X is higher than the heat capacity of Y.
Okay, the heat capacity of object X is higher or bigger, okay, than the heat capacity of object Y. This class is only me and Wong Yik Suan only, is it? Nobody else in this class. Come on, people. Okay, don't be so cool, and sorry, don't be so kedekut ilmu and just keep everything to yourself only. Come on, you're better than that. Okay, compare the rise in temperature.
The increase in temperature of object X is less than object Y.
Okay, very good. Okay, the increase in temperature, the rise in temperature in object X is less than the increase in temperature in object Y. Okay. Yes, very good. Okay, so which object is hotter? This is okay, never mind. This one I'm not even going to bother lah. I think it's too simple. So object Y is obviously hotter lah because it has a bigger increase in temperature. Okay, so this is the most important thing. The object with a high heat capacity heats up slower. Okay, it becomes hotter slower. Things with small heat capacity become hotter faster. Okay, the single most important thing that you need to remember today is this. Okay, like short-tempered people and hot-tempered people. Okay, I am very proud to say that I'm very long-tempered because if I'm very short-tempered, I would immediately be angry. I already say, please answer everybody, and everybody's just giving me the cold shoulder as if I'm some form of non-human. Okay, come on. Okay, so yeah, so appreciate the teachers who have long temper. Okay, so object A and B are made from aluminium but have different heat capacity because they have different masses. Look at the mass of this one. This is 1 kilogram, this is 2 kilogram. But in order for it to rise by 1 degree Celsius, we need to provide 900 joules of energy to the 1 kg and 1,800 joules to the 2 kg. So the bigger your object is, even if the object is the same, okay, the bigger the object is, you need more heat to make it become hotter. Okay, which is the point of this slide lah. Okay, so in that sense, the heat capacity of B is bigger than the heat capacity of A. Okay, because it needs more heat to make it rise by 1 degree Celsius. And the thing that is different about this is the fact that it is the same material but different mass. Just like the situation with the water in the pool and the water in the pail. Same material, both is water, but the mass is different. Okay, so two important factors when we talk about the increase in temperature. Okay, two important factors is number one is the type of material. Okay, just now it's object X and object Y, different types of material. Okay, the second one, it can be the same type of material, but different mass. These are all factors that affect how much heat is needed to raise the temperature by 1 degree Celsius. Different materials, different mass. Okay, things that we have to think about this lah. Okay, let's take a look at this 1 liter, 2 liter. Tell me which kettle boils for a longer time. So now it's so logical. Which one will take a longer time to boil? Okay, it will be kettle Q. Obviously, it will be kettle Q. Which one has a larger quantity of heat?
Kettle Q.
Kettle Q. Okay, it will also be kettle Q. And because of that, the one with the large heat capacity will obviously be kettle Q because there's more water inside. Okay, we don't think about this when we do this, Okay, because we're so used to this. Kalau banyak air, bahkan dia mengambil masa yang sangat lama untuk menjadi panas. Kalau sedikit air kan sekejap dia jadi panas. But we never think about it from a scientific point of view, which is exactly why we're doing this. Okay, exactly why we're doing this. We need to make a scientific explanation for everything that happens in everyday life. Otherwise, there's no point being in science class. Okay, is to give reasons to why things happen around us. Okay, make an inference about the relationship between the heat capacity and the mass. Okay, can you tell me what is the relationship between the heat capacity and the mass? I've taught you how to write the relationship.
Higher mass, higher heat capacity.
Higher mass, higher heat capacity. Okay, very good. The greater the mass, the greater the heat capacity. This is a standard and very boring answer. Whoever that answered that just now, sorry, I don't know who answered that just now. Thank you. It's a good answer. The bigger the mass, the bigger the heat capacity. Okay, but this is how we write the relationship. Most important thing is that you don't terbalikkan the relationship. Think about this, if I say the bigger the heat capacity, the bigger the mass. Doesn't make sense, because the mass affects the heat capacity. The heat capacity doesn't affect the mass. Okay, you mean somebody with bigger heat means the mass is bigger? Not necessarily, no. Okay, the greater the mass, the bigger the heat capacity. The order is very important. Okay, so the factors that affect heat capacity is number 1, mass, number 2, rise of temperature, and number 3, material or substance. How much heat capacity a material needs depends on these 3. What is its mass, what is its rise of temperature, and what is the type of material. Lain-lain bahan, lain-lain lah dia punya heat capacity. Okay, and so now we move on to activity number 2. Okay, activity number 2, I'm only going to answer question number 1 and number 5. Okay, and your assignment today will be question number 2, 3, and 4. I want you to explain to me. Okay, write down lah. Okay, and explain. So the daily situations which involve heat capacity. Number 1, explain why a cup of hot coffee can cause more injury on a body than a drop of hot coffee. How many of you have had the unfortunate experience of having hot water spilled on you? I have. Okay, so it's a different feeling, if just a drop of hot water yang terkena kamu bahkan, okay, it doesn't injure you so much lah. But if somebody pours a cup of hot water on you, or okay, fine, nobody pours lah, nobody's that dumb. So somebody spills a cup of hot water lah, okay, on you. Obviously, you're going to have a bigger reaction, right? Okay, why? Okay, so why? It will be because the water from a cup of hot coffee has a higher heat capacity. Okay, higher heat capacity means what? It has more heat inside. Okay, and when that heat is transferred to you, obviously you're going to be in pain compared to a hot drop of coffee. Drop of hot coffee. Okay, because drop of hot coffee sikit saja dia punya haba di dalam. Okay, the heat capacity, the heat inside the drop of hot coffee is very little. It is the same drink. Both is coffee, but the mass is different. Okay, dia punya berat, dia punya jisim adalah berlainan. So the water from a cup of hot coffee has a higher heat capacity compared to a drop of hot coffee. On the body. Same thing with hot soup. Okay, after being left to cool for some time, the soup in a large bowl is hotter compared to the same soup in a small bowl. Okay, we do this every day, especially those of you who every time dinner you drink soup. Okay, after some time let's say after half an hour, you put your thermometer, don't put your hand put your thermometer inside the original, the pot, and you put the thermometer inside the bowl. You find that the soup has cooled down a lot. Manakala the cooking pot, the soup is still pretty relatively hot. Why? Why is this? Okay, nobody asks why, because everybody doesn't ask the important question. The important question as scientists, as humans not just as, I think it's a human thing. Okay, as humans the basic question we must always ask is why is this like this? Okay, have you ever thought, or you just accept the fact, just like everything else that is going around in your life, you just accept the fact, this is what it is lah. Begitulah dia punya kejadian itu. Oh, okay, we need to ask ourselves why. Why? Because the soup in the large bowl has a greater heat capacity. This one is not in your module I'm just showing you lah. Okay, this is how to answer and how to give a proper explanation, okay, to this kind of situation. The soup in a large bowl has a greater heat capacity because it's so much more. Okay, so it cools down at a slower rate. Cools down at a slower rate means in normal words means it takes a longer time to cool down. If you write like that, also no problem. Okay, the point is I want to know why, and then after that I want to know so. Okay, why is it that the soup is hotter? Because it has a large heat capacity. So it cools down at a lower rate. So it takes a longer time to cool down. If I flip it the other way, Let's talk about the small bowl. The soup in the small bowl has a smaller heat capacity. So it cools down faster. It cools down at a faster rate. Can lah. Okay, it takes a faster time to, dia lebih cepat sejuk lah berbanding dengan the soup inside the pot. Okay, so today evening, if you have soup for dinner, think about this situation. Okay, think about why when you, I'm not saying that it becomes like ice cold, but I'm saying compared to the big pot of soup, it's definitely much cooler in the bowl. Okay, which is why nobody in their right mind, so last time when I was in university, a lot of students, they always do this, no? They cook their Maggi inside the pot and then they eat directly from the pot. And I'm like, what? Why would you do that? It's so illogical. And then after that, they complain that their tongue get burned and everything. Of course your tongue will get burned if you eat Maggi directly from the pot. Okay, such a brainless thing to do. Okay, put it inside a bowl, or actually even better, you put it inside a plate so there's more surface area. And it cools down faster, then you can eat without burning your tongue. Okay, so, okay lah, confession lah, I also do the same thing lah, because I'm very lazy. Okay, but the fact of the matter is, because you're lazy, okay, that's why your tongue get burned lah. Kan, sometimes if you do the most illogical things, and if things happen to you, okay, the only person you have to blame is yourself. Okay, so put it into a bowl. Okay, nobody, at least nobody in their right mind that I know of, okay, drinks the soup directly from the pot. Okay, unless you really want to get your tongue burned. Watermelon and sandwich taken out from a fridge. Okay, of course the watermelon you already cut lah. And then you find that after 30 minutes, the watermelon is still cooler than the sandwich. Okay, tell me, which one has a bigger heat capacity? Watermelon or sandwich?
Sandwich.
Sandwich has a bigger heat capacity.
Watermelon.
Watermelon has a bigger heat capacity. I feel I'm teaching in a boys' school, and only the boys are answering. I'm hardly hearing anything from the girls. But there are more girls in this class. Think about it. Why does the watermelon stay cool for a longer time? I don't know how many of you eat sandwich from the fridge, but you take a sandwich out and you take the watermelon out, you find that the watermelon stays cool for a longer time. You take it out at the same time, the sandwich gets hotter faster. Why? Who has the bigger heat capacity? Watermelon or sandwich?
Watermelon.
Watermelon. Okay. The watermelon heats up slower compared to the sandwich. Now, this is a very important thing. If you have a big heat capacity, you not only heat up slower, but you also cool down slower. Okay, it takes a longer time for you to become cold, and it takes a longer time for you to become hot. It's true, you put the sandwich and the watermelon into the fridge, okay, the sandwich will become colder faster, okay, compared to the watermelon. Okay, let's go to the next thing. I will talk about the assignment number 2, number 3, number 4 is your assignment, but I'll talk about this in a little while. Since you're talking about heat capacity, we need to talk about specific heat capacity. Okay, specific heat capacity is just another addition to the word, but it standardizes a lot of things. Okay, let's think about these two situations. So the rise of temperature by 1 degree Celsius for 1 kilogram of aluminium and 1 kilogram of plumbum, PB is plumbum, okay, we see that in order to increase the temperature by 1 degree Celsius, you need 900 joules of heat for aluminium. But the conditions are the same. The only thing that has changed is the plumbum, but you only need 130 joules. So my question is, which substance needs a large amount of heat to raise the temperature by 1 degree Celsius? Obviously, the answer will be aluminium. And why is this? Because different quantity of heat is needed to rise the temperature by 1 degree Celsius for two objects A and C, even though their masses are equal. Now we are making the mass equal. So the difference between heat capacity and now we're looking at specific heat capacity. Why we say specific? Okay, because we want to standardize one thing. Specific refers to 1 kilogram. 1 kilogram of any material. Okay, we change the material, but we don't change the mass. Okay, that's why it's called specific heat capacity. Specifically, 1 kilogram. 1 kilogram of water, 1 kilogram of oil. Okay, which one will take up a longer time to become hotter? Obviously, it's the water. Water takes a longer time to become hot. 1 kilogram of aluminium, 1 kilogram of plumbum. Okay? Plumbum takes a faster time to become hotter because all you need is just 130 joules of heat already increased by 1 degree Celsius. Okay, so different objects have different specific heat capacity. And it is this value that helps us to know whether some things will become hotter faster or takes up a long time to become hotter. Plumbum heats up faster than aluminium because it needs less heat to raise the temperature by 1 degree Celsius. Okay, we're not even talking when we talk about specific capacity, right? We're not even talking about become hotter actually. We're just talking about kasi naik 1 degree Celsius saja. Okay, because in heat, the amount of heat you use to raise 1 degree Celsius is the same amount of heat you use to raise the next degree Celsius. Okay, it doesn't mean that if something becomes hotter, it needs less heat to become even hotter. It's not true. You want to raise, okay, let's say water at 27 degrees Celsius, you want to change to 28 degrees Celsius. 1 kilogram of water, sorry. 1 kilogram of water, you want to increase the heat, you want to increase the temperature from 27 to 28, is the same as the amount of heat you need to increase from 90 to 91 degrees Celsius. Same amount of heat. It doesn't mean that just because the water is hotter means you need less heat to make it even hotter. Something that we have to unlearn and we have to learn again. Okay, a lot of people make this mistake. They think that because something is hotter, so it doesn't need so much heat to become even hotter. Totally false. Okay, heat doesn't work that way. Heat works very methodically. 1 degree Celsius means this amount of heat. Okay, needed. Doesn't matter whether the thing is originally hot or originally cold. Doesn't matter. Okay, you want to change the water from 2 degrees Celsius to 3 degrees Celsius. Just kasi naik 1 degree Celsius sudah. It is the same amount of heat. Okay, all across the board. 1 kilogram of plumbum needs 130 joules of heat. Okay, this one already mentioned lah. So the definition of specific heat capacity is the quantity of heat needed to raise the temperature of 1 kilogram mass of the substance by 1 degree Celsius. It is, this is in Form 4 lah. Okay, in Form 4, this chapter has a lot of definitions that are very long and a little bit tough. Okay, but it's very important. The amount of heat you need to raise the temperature of 1 kilogram mass of the substance by 1 degree Celsius. Okay, it is almost the same as heat capacity. Heat capacity is the quantity of heat needed to raise the temperature of a substance by 1 degree Celsius. Only this word is not there, of 1 kilogram of mass. So when we say the word specific heat capacity, we just need to include the words 1 kilogram of mass. Okay, so just now the formula is C equals to Q over delta theta. Okay, but now since we are having, big C, now since we're having specific heat capacity, we need to include the mass inside. Okay, because specific heat capacity is with 1 kilogram. So heat is Q, mass is M, delta theta, actually, yeah, I like to use delta theta, delta theta is the rise in temperature. Rise in temperature means, okay, it can be rise, it can be decrease. Okay, change in temperature lah. Okay, C is a specific heat capacity. Specific heat capacity is a constant. Different materials have different specific heat capacity. You don't have to memorize them. Okay, it is given to you. What you have to memorize though is the formula. Okay, so the unit for heat is joule, the unit for mass is kilogram, the unit for increase in temperature is degrees Celsius. Okay, let's put it here. This is joule. Okay, this is joule. Over mass is kilogram and change in temperature is degrees Celsius. So when we combine all this together, we will get this formula. Joule per kilogram per degree Celsius. Okay, joules per kilogram per degrees Celsius. And so when we move this up, okay, if I move this up, I can actually calculate the amount of heat. Okay, the quantity of heat that you need, okay, is dependent on 3 factors. The specific heat capacity, how much temperature you want it to rise, and the mass of the object itself. Okay, so important formula for today. So what is the meaning of the specific heat capacity of aluminium 900 joules per kilogram per degree Celsius? It is probably the longest unit in your entire physics syllabus. This is a very long unit. Joules per kilogram per degree Celsius. What it means is this. 1 kilogram of aluminium needs 900 joules of heat energy to raise its temperature by 1 degree Celsius. Mau kasih naik 1 darjah Celsius je, you need 900 joules for 1 kilogram, okay, of this one. Okay, let's translate this into this situation. What about this? Water. The specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. Okay, can you write down what is the meaning of this 4,200? The meaning of the specific capacity itself is a struggle. Okay, so the more you write it, the more you read into it, okay, the more it will make sense. Okay, so this will be the answer. 1 kilogram of water needs 4,200 joules of heat to raise its temperature by 1 degree Celsius. Take a look at these two sentences and take a look at the difference and the similarities. Okay, this one is aluminium, this is water. The word is the same. 900, this is 4,200. Everything else is the same. Okay, so you should be able to tell me, if I give you a number, okay, if I give you a number of a certain material, okay, for example, just now plumber, oh gosh, I can't remember. Let's say okay, let's say oil, okay, specific capacity is 2,500 joules per kilogram per degree Celsius. 2,500. So you should be able to tell me the meaning. 1 kilogram of oil needs 2,500 joules of heat energy to increase the temperature by 1 degree Celsius. Okay, so understanding this meaning, how to how to write this in a sentence that makes sense, okay, is something that you need to master. Okay, something that you need to, you need to know and you need to remember. Okay, the meaning of this number. These numbers got meaning, right? No, it's not just numbers that are simply given to you for the fun of it. Okay, there is a meaning to this number, and there is a meaning to this this unit. Okay, 1 kilogram of whatever material needs so and so amount of heat, joules of heat, okay, to raise its temperature by 1 degree Celsius. Okay, the question that you need to ask yourself is, what is the meaning of 4,200 joules of heat? What is the meaning of 900 joules of heat? Okay, that's a question for another day. Okay, not for today. But suffice to say that the bigger the joules, the bigger the amount of energy, the more the amount of heat. Okay, the thing that we should take back with us today. All right, let's do these two questions and then we will call it a day. Okay. Oh no. Question number one. Sorry, question number one. Metal has mass 2 kg. Okay, calculate the amount of heat that must be transferred to raise the temperature from 30 to 70. So the formula is this. Okay, calculate the amount of heat means calculate the value of Q. Mass is 2 kg. Yeah, mass is 2 kg. Okay, the C is given. As I said just now, the specific capacity you are not required to memorize, but you have to, uh, you have to, sorry, you have to know what it means. It means, okay, what does this 500 mean? It means 1 kilogram of whatever this metal is needs 500 joules of heat energy to raise the temperature by 1 degree Celsius. Okay, so we substitute inside. M is 2, 500 is the C. The increase in temperature is 40. How do you get 40? Because it wants to go from 30 to 70. So 40 degrees. Okay, that means this particular metal has to menyerap 40,000 joules of energy, okay, in order to increase the increase the temperature from 30 to 70. Oh, I guess I can tell you this now. Okay, fine. The mass is 100 grams. The C is 120. Is it 129? Yeah, 129 joules per kilogram per degree Celsius. Okay, and it wants to increase from 20 degrees Celsius all the way to 100 degrees Celsius. Am I right?
Yes.
Okay, calculate the amount of heat. What is the value? What is the answer? Q.
1032 joule.
1032. Okay. You're right lah, obviously. Okay, the answer is 1032 joules. Most important thing is if you use 100, wow, cannot. Okay, remember to change the mass into kilograms. Okay, so you should get 1032. This is wrong, this should be 80. Okay, 100 minus 20 will be 80. Okay, so we will do more calculation questions as we go along, except that today I just wanted you to know what is heat capacity, what is specific heat capacity, how to calculate both. Okay, specific capacity and heat capacity. But more importantly than that is actually the explanations. So your homework for today, okay, which I would like you to complete today okay, don't like bring it to the next few days lah. So in page 86, in page 86 in your module, I want you to give me the explanations for question number 2, number 3, and number 4. Okay, then what you do is you snap a picture and then you send it into the homework channel.